Here's the problem we got for today. Find the volume bounded by z equals 1 over x squared over y squared. So here's what we have to do. We start with the z, x, and y plane. There's z, there's y, and here's x. Label them up, z, y, x, and we're ready to get started. First things first, draw what the curve looks like. I don't know what this looks like, but it looks pretty cool, maybe. So who knows, maybe this looks something like this. I'm just guessing here, honestly. So here's maybe a extremely false depiction of what our surface here might look like, but it's a surface. This could be 1 over x squared y squared, and yeah, we have to find the volume bounded by this curve on a certain domain from 1 to infinity, okay, for x, and 1 to infinity for y. That's the domain on which we have to find the volume under this curve. So how do we begin? Well, we already know the limits of integration are going to be 1 and infinity, and since our region R on the xy plane is a square, essentially, right? It goes from 1 to infinity for both x and y, from 1 to infinity, and from 1 to infinity. Since it's a square region, it doesn't really matter if we do dy or dx. So I'm just going to go ahead and write dy dx, okay? So z dy dx, and we're evaluating from 1 to infinity, from 1 to infinity. Okay, first things first, let's go ahead find out what do we do. So instead of writing z dy dx, I'd much rather plug in what z actually is. Okay, so so let's plug in z is 1 over x squared y squared, right? And then we got dy dx. Again, doesn't matter what order you choose, since region R, this region R right here is a square, so it doesn't matter our order of integration. So first things first, we're integrating with respect to dy. So this y squared on the bottom, I actually like to write it as y to the minus 2. That helps me kind of mentally understand how I'm going to integrate things. So let's do the business. Y to the negative 2 integrated just becomes negative y to the negative 1. So we're going to have, I'm just going to switch up colors a bit. So I'll have 1 to the infinity, and inside I'm going to have x to the negative 2 and minus y to the negative 1 evaluated from y equals 1 to y equals infinity, and on the outside I'll be integrating with respect to x, since I already did the y part. So what am I going to have here? I'll have 1 to infinity of, well, let's just plug in here. If I put in infinity here, let's do the math, x to the negative 2, by the way this is a times symbol, times negative y to the negative 1 plus y to the negative 1. Okay, here of course I'm gonna put in infinity instead of y. Okay, and here I'm gonna put 1 instead of y. So now let's see where that takes us. Infinity, of course, to the negative 1th power. That's of course theoretical. Bless you, audience. This is completely theoretical. So this infinity to the negative 1th power just devolves to 0. And so we're left with 1 over 1, which is just 1. So we're taking really the integral from 1 to infinity of, let's write that infinity nicer. We're taking the integral from 1 to infinity of x to the negative 2 dx. And so what does this become? Well, this will become x to the negative 1 via the inverse power rule times negative 1. And we're evaluating this from 1 to infinity. So what is that going to give us? It's going to give us minus infinity to the negative 1 plus 1 to the negative 1. Minus infinity to the negative 1, we've already said. This goes to 0. So we're left with 1 to the negative 1. And of course 1 to the negative 1 is just going to give us a final answer of 1. And that, ladies and gentlemen, this right here is our answer for the question. And that's how you find the volume bounded by an improper multivariable integral. Thanks for watching. We'll check you out next time.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.